All right, we're going to start lesson 5.3 today, and this lesson's on scatter plots and lines of fit. Okay, so you're going to see, how we're applying what we just got done working on, which is being able to write equations in slope-intercept or standard or point-slope form. That is going to be part of what we do today. We're going to start looking at applications of writing those equations, and that's where we get into our scatter plots and lines of fit. Okay, so first of all, a scatter plot is simply a graph of bivariate data that consists of ordered pairs on a coordinate plane. So basically, it's graphing points. Um, we're going to graph a group of points on a coordinate plane, and we're going to look at the relationship between what the x represents and what the y represents, and how those two work together. So we're going to give some meaning to the whatever the combination of ordered pairs are, what they represent, and look at the meaning of that and how it plays out. The line of best fit is just that. It's a line that we're going to draw in the scatter plot. It's going to evenly divide the points that are graphed. All right, so we're just going to draw it down through all the points so that we split the points kind of evenly. And basically, we're going to write equations to represent this line, and we're going to use the line to make some predictions. But we'll show you how this works in a little bit. And then the trend of the data is just a general pattern of the data. And the trend can be positive, negative, or there could be no correlation. And we talk about correlation to how the two variables relate to each other. So if I look at this cluster, you can see this cluster. It doesn't form a perfect straight line, but you can definitely see that it's kind of grouped itself to form a cluster that's going upwards. All right. Now, if I was to draw a line through here, this line would have a positive slope. It's going up from left to right. So this is a positive correlation. And we say as our x values are increasing, the y values are increasing. That's positive. Okay, a negative correlation is the points kind of cluster to show you a line that would have a negative slope going down from left to right. So as x increases, the y values are decreasing. That shows a negative correlation. And then there's no correlation for a collection of ordered pairs, and it's just this. There is no, clustering of points to show an increase or a decrease. They're just kind of scattered all over. So we just say x and y aren't particularly related in any kind of a correlation. Okay. All right, so looking at scatter plots and correlations, let's first talk about the scatter plot that we're given. So this scatter plot is showing the weight and fuel efficiency for 21 vehicles. Also shown is the line of best fit for the data, and our job is going to be to answer some questions. But first, let's look at this. So our x-axis is representing the weight in pounds of the vehicles, and the y-axis is the fuel efficiency in miles per gallon. So this is bivariate. One variable, the x is the weight, the other variable, y, is the fuel efficiency. So we're looking at how weight and fuel efficiency work with vehicles. Okay, so they took some different vehicles. These little x's represent different vehicles that have obviously different weights and different fuel efficiencies. And then what we've done is this blue line is what we call our line of best fit. It's the line that divides the data most evenly. Okay, and so right now we just need to know that's what it is, and we're going to use it to help us make some predictions. Okay, so the first question says, for these 21 vehicles, as the weight increases, fuel efficiency tends to do what? So as weight increases, fuel efficiency is coming down. All right. So is it increase, decrease, stay the same? You're going to have drop down boxes today. The answer is as weight increases, fuel efficiency tends to decrease. So the heavier the vehicle, the less miles per gallon it's going to get. Okay. For these 21 vehicles, there is a blank correlation between weight and fuel efficiency, and your choices are positive, negative, or no. So the correlation is related to the line. So the line has a negative slope. It goes down from left to right. So this has a negative correlation. We say it has these two different variables here have a negative correlation. As the weight gets heavier, the fuel efficiency comes down. And then part C, using the line of fit they have drawn in here, what would you predict a vehicle that weighed 3,000 pounds would have for fuel efficiency? All right, so go to 3,000 pounds on the x-axis, take it up until you hit our line of fit, not for the x, till you hit the line of fit, and then bring it over and see what that ordered pair would be. And your choices are 27, 29, 31, and 33. Okay, it's just below 30, so I'm going to say it's 29. So we would be 29 miles to the gallon. Okay, so there's a look at a scatter plot and a line of fit, and then asking some basic questions. Here's another one. This scatter plot represents the number of hours worked down here and the amount of money spent on entertainment by 25 students. Okay, so here's every one of these X's represents one of the students. Okay, each, like this student here, worked 12 hours and spent about $25. Okay, now you see the line of fit is drawn in here. This line of fit is dividing this data evenly. It's breaking it in half, top and bottom. Okay, so it's the line that divides the data most evenly. First question, for these 25 students, as the number of hour increases, the amount of money spent tends to do what? So as the hours worked increases, the money spent increases. That is a increase. Okay. Part B, for these 25 students, there is a positive, negative, or no correlation between the number of hours worked and the amount of money spent. Well, obviously, as the hours go up, the money spent goes up. These are clustering to form this positive correlation. So there is a positive correlation between these two. And then finally, using the line of best fit, let's make a prediction for a student who works 12 hours, how much would they spend? So you go to the 12, take it up to the line, not to the X, to the line, because this line is our predictor here, and take it across your choices, 25, 27, 29, or 31. It looks like we're just below 30 again, so I would say we're at 29. Okay, so there's how we read a graph for a scatter plot and how the line of best fit works. Okay, it says here, the data points on the scatter plot show the amount of time spent watching television and the amount of time doing homework the last week for 25 students. So each one of these X's represents one of the students. It asks you now to draw on your line of best fit. And notice here it says it doesn't have to be exact. All right, just a good approximation. So if you think about it, if you draw a line down through here so that you're going to divide the data, so that you get X's above and below the line about equally, hopefully you're going to get something like this. Now, there are also, all of ours are going to be just a little different, okay? But we should all trend in this very, very similar path right here so that the data is split like this. And all you have to do today is drop this line in for this question. Okay, another one. This shows the number of hours worked and the amount of money spent by entertainment by 21 students. Again, drawing the line of best fit. It doesn't have to be exact. So obviously we're looking at a positive correlation as the number of hours worked goes up, amount of money spent goes up. So we're going to try to fit our line in here so that we're dividing the data. And again, you're just going to put a line in there and something like this. Okay, I'm not counting exactly, but it looks like, the number of X's above and below are pretty close, and our line is working its way up through the data like that. Okay, so that's all you have to do is put in that line of fit. Okay. Now let's make some predictions from the line of fit. And this is a little bit advanced because you notice, let's first of all, I guess, look at the scatter plot. It says the scatter plot below shows the number of years experience, X. So X is our years of experience. Y is the hourly rate of pay for cashiers in Texas. Okay. So we got 23 different X's up here, and they have already generated this line for us. And they told us what the equation is. All right, so this line is this equation. So use this equation, y equals 0.94x plus 7.96 to answer the questions below. All right, A, for an increase of 1 year in experience, what is the predicted increase in hourly pay? Well, you understand what this equation represents. X represents the years of experience. So every time I gain a year experience, I get to multiply it by 0.94. So the 0.94 is our rate of change. That's what's changing. So that represents our hourly pay increase in a year. That's the rate of change, 0.94. What is the predicted hourly rate for a cashier who doesn't have any experience? So now take our equation and put 0 in place of X. No experience, 0 years experience. That will cancel it out. And guess what you're left with? Well, that's the y-intercept. So at 0 years experience, come down here, that's where we would expect the line to cross the y-axis. That's our y-intercept. 0 years experience is our y-intercept. We're expecting it to be at about 7.96. So if you have no experience, you're going to start making about $7.96 or $7.96 per hour. And then what is the predicted hourly rate for a cashier with 5 years experience? Now, we could go up here and make a guess. I could take 5, come up here to the line and come across. But what we want to do is let's make the most accurate answer we can. Take our equation And in place of X, put 5. So 5 times 0.94, add them together. There's your exact answer, 12.66. According to this equation that's been written for the line of fit, that's the most accurate equation we can get. This is the most accurate answer to that question, 12.66. So we use the equation to get this answer. Okay, let's look at another one. So this shows the time spent watching TV. That's our X. Time spent doing homework is our Y. Again, bivariate data. There's my two different variable concepts by 24 students. So there's 24 X's up here. They have already generated the line of best fit. That's this blue line. And they're telling us what the equation is. Notice that my slope here is negative 0.77. We're going down, right? Negative slope. The predicted y-intercept is right here at 26.8. So if I bring this line up to where I hit the y-axis, it's going to hit at about 26.08. So let's answer some question. What is the predicted time spent doing homework for a student who doesn't spend any time watching TV? Okay, so remember the time watching TV was X. So if I put 0 in place of X, okay, that's going to tell me the y-intercept, which is 26.08. Oops, I wrote 28. It should be 26.08. So a kid that doesn't watch any TV, we would expect them to do about 26.08 hours of homework. Okay. For an increase in 1 hour of time spent watching TV, what is the predicted decrease in time spent doing homework? Okay, so remember, this is our rate of change. Every hour we spend, we go down by 0.77 hours of getting work done, right? Every hour spent watching TV, we're going down by this much. So we would predict we would go down by 0.77 hours for every hour we watch TV and doing homework. And then finally, what's the predicted time spent doing homework for a student who spends 18 hours watching TV? Use your equation, right? Here it is. We got negative 0.77x plus 26.08. Put in our 18 for X because again, X is the hours spent watching TV. And it comes out to be 12.22. So let's just see over here. If we go to 18, which is between these two up here, it's just past 12. So obviously we're pretty accurate right there. So that's another style of question we can do with scatter plots and lines of fit. Okay, the last one is for us to actually do it. Okay, so the scatter plot below shows the time spent texting and the time spent exercising for 25 students. So there's my 25 X's up in there. Okay, A, write an approximate equation for the line of best fit for the data. It doesn't have to be exact. Everybody's could be a little different. Okay, so what we're going to do is rough in our line. Here's our line. We put this in and we look above and below and feel pretty good about that. All right, now what I'm going to do is choose 2 points that are on my line. And I'm approximating. At 1, I figure out I'm about 8.1. I'm just above here. And at 9, I'm about here at 2. So I'm going to take those two ordered pairs. That should say 8.1, not 1.8. My apologies. I'm going to take these two ordered pairs and do what we've been doing the last several days. Write an equation. Okay, what do I need? The slope. So difference in the y's, 2 minus, again, that's 8.1 over 9 minus 1. I get negative 6.1 over 8, which is about negative 0.7625, and I'm going to call it about negative 0.76. It makes sense that that's negative because our slope is going down. Our line has a negative slope. Okay, now what do we do next? We take the slope and one of these 2 points and we write the equation. So I'm going to go point slope form. Y minus 2 equals negative 0.76 times x minus 9. Distribute my negative 7.6 through, add 2. There's my equation. So there's my equation. Now yours may not be the same. If you adjust this at all, it's not going to be the same, but we're going to be really close. Okay, and that's the idea. We're going to be close together here. All right, use your equation from part A to predict the time spent exercising for a student who spends 5 hours texting. So let's use the equation. Here's the thing that generates our answers. Put 5 in here for X, because remember, 5 is the number of time spent texting. That's down here. And we're going to get about 5.04 hours. So let's take a look here at 5, come up, boom, just a little bit past 5 up here. I would say that's pretty close. Okay, so that's how we write our line of fit. Okay, let's do another one. So this shows the number of years experience and the hourly rate for 23 cashiers. So there's 23 X data points up here. Here's years experience, here's pay. we're going to write a line of best fit. So the first thing we're going to do is rough our line in, and then we're going to choose some points. So I'm going 2, about 8.5, probably closer to 9, but I'm going to go 8.5, and I'm going to go 20, about right at 17. Okay, now if you choose 2, 9, that's fine. Again, we're going to be close. We're not all going to be perfect here. So I'm going to take these 2 points, and I'm going to write an equation for a line that goes through these 2 points. So the first thing I need is slope. 17 minus 8.5 over 20 minus 2. Get about 0.472222. I'm going to call it about 0.47. So that's my slope. It's positive. We're going up. Write the equation. Start with point slope. So y minus y1 equals m times x minus x1. Distribute. Okay. Add 17. I get y equals 0.47x plus 7.6. There's my equation that represents this line, which represents the line of best fit. Use this equation to figure out how much a cashier with 10 years experience would make. Okay, so I'm going to take my equation. I'm going to replace x with 10. Work the numbers, about $12.30. So if they got 10 years of experience, we'd expect them to make about $12. Come up here, 10, hit my line. It's a little bit more than 12, $12.30. All right, so that's a little bit about scatter plots and lines of fit. You're going to work these concepts today. The homework questions are very similar to what I just went over with you. All right, so I will let you have at it.